Lesson 4.4 is about two-way tables, and this continues talking about bivariate data. Two-way tables show frequencies of data categorized two ways. The rows indicate one category and columns indicate another. And so these two different types of categories are kind of like variables, but we don't use variables in these types of problems, but that's what they are. And so that's why this is considered to be bivariate data. Example 1, complete the two-way table. So you see a two-way table here, and it tells you a weatherman asks 75 people from 2 cities if they own rain boots. Complete the table. So we have 75 people polled, and you see that the columns are talking about rain boots. Yes, they own rain boots, or no, they don't own rain boots. Notice that the rows are talking about the city they're from. They either come from city A or city B. And we're just going to plug in using numbers in this two-way table. We have been given totals for rows and columns. In some cases we're finding totals, and we can decipher what these are. So, looking at this first row, this is for city A. People either own rain boots, yes, or they don't, no, and then it gives a total. So we have blank plus 19 equal 32. So I'm just going to think about that for a minute. Blank plus 19 equal 32. How would I figure out what that missing blank is? I could just add something plus 19 to get 32. I could say 32 minus 19 to find out what that value is, but I'm going to get 13. Oops. So I'm just going to plug that in here. I get 13. Okay, looking at the columns, I don't really know enough to get row B. I've only got 28 yes that have rain boots. I don't know how many don't and what the total is. But on this first column, yes, they own rain boots. I see that 13 are from city A, 28 from city B, and I can get that total by saying 13 plus 28 equal blank. And so 13 plus 28 would be 41. So I can plug in 41 there. We're just filling in information as we find it. This next column, no. I have 19 plus blank equal 34. So I could just subtract 19 from 34 to get what's left, which would be 15. And 19 plus 15 is 34. So that works. And now I want to get these totals. So to get totals, I could just add those up. So I can say, okay, for B, let me erase this. For that column B, row B, 28 plus 15 equal blank. And they add up to get 43. Now to get that total in the bottom right corner, I could do this a couple different ways. So I'm looking for this total right here in this bottom right corner. And so I could say this row, that's a total of 41 plus 34, 41 for yes they have rain boots, plus 34 for no they don't have rain boots, equal 75. And so I get 75 using the row. I could also use this total column and say, okay, I have 32 plus 43, add those together, I also get 75. So either way, whether I use the total column or the total row, I get 75. Notice that we were also given 75 right here in the problem. And so we have completed this two-way table. We just used information that we knew that we were given to figure out the missing pieces. And notice there were multiple ways to figure them out. Example 2. A poll was taken of children and adults to see if they prefer tennis or volleyball. So I see the two-way table that's given here. Notice that you have a row for children, whether they chose tennis or volleyball, and the total children polled. You have a row for adults, whether they chose tennis or volleyball, and the total number polled. And you have a row for the totals. 80 chose tennis, 60 chose volleyball, and 140 were the total that were polled all together. Notice it's the same number for the column for total and for the row for total, and that's how that will always show up. So now we're going to answer some questions from this information. So part A says, what percentage of those polled prefer volleyball? So we want to find a percent of those polled that prefer volleyball. So look at the total that were polled. The total was 140. And look at how many preferred volleyball. We go to volleyball and go all the way down to the total, and it's 60. So out of those polled, that's your total. The ones that chose volleyball, that's your numerator. So we've got 60 out of 140 as a fraction. And we want to go from a fraction to a percent. So think back to 7th grade. We take the fraction and we divide the numerator by the denominator, or you can use your calculator to convert fraction to decimal, either one. And we get 0.4285, and it just keeps on going. And if we moved our decimal 2 places right, we'd get 42.8, which is about 43%. About 43%. So about 43% of those polled chose or prefer volleyball. That makes sense because it's a little less than half. Part B, what percentage of children prefer tennis? So we're going to say that out of all the number of children that were polled, how many prefer tennis? So we go to the total number of children polled. So we look at children and go all the way to the total. There were 70 children polled. And then looking on that same row of children, look at tennis, and there were 24 children that chose tennis. So that's our fraction, is 24 out of 70. When we divide that, we get the decimal 0.3428 ... And that rounds to about 34%. When we change our decimal to a percent by moving it 2 places right, it rounds to about 34%. C part, what percentage of those who prefer volleyball are adults? So we're going to find out of those who chose volleyball, how many of those were adults? So we go to the column for volleyball and go all the way down to the total, and 60 people chose volleyball. And then looking at that same column, go to where you see adults, and there were 14 off the row from adults that preferred volleyball. And so 14 divided by 60 is 0.2333 ... The 3's kept repeating. And so that is about 23%. Notice in all of these cases that the total amount that you were looking for, the denominator, was the word or phrase given first, and the portion of that, the numerator, was the word or phrase given last. That's the most common way you'll see these types of questions asked.